Hey team, Dr. Jake Cordy here, and in the previous few videos I've been covering how the immune system works, how it fights pathogens, but then how it can go wrong. And I covered how inflammation can contribute to disease, then I covered autoimmune disease. Now I'm going to cover allergies. Now these beautiful images right here are actually of pollen. Now pollen is weirdly autofluorescent. You don't need to stain it. It just naturally fluoresces beautiful colors. So here is some microscopic pollen fluorescing. And that's up there because obviously pollen allergies are a very common thing. But let's jump into allergies. Now, the first thing to know about allergies is they're massively increasing. If you ask your parents how many kids in their class had an allergy, they would probably say none or maybe one. But if you ask now, the percentages are through the roof. Somewhere around 1 in 6 people have some sort of allergy, depending where you are in the world. Now, this is just a graph of emergency department visits induced by anaphylaxis per 100,000 children. Starting in 2005, we can see even in that 10-year period, we see this massive increase in anaphylactic shocks, which is a massive allergic response. And here is just peanut allergy incidence, percentage of total births over the last 16 years from 2001 to 2017. It's gone up 2.5-fold. And we really don't know why. We really don't know why. There are a few theories out there, but the specifics of that, we really don't know why. And I actually jump into a few more specifics in a later video. In a different playlist if you want to check that out. But if you ask immunologists fundamentally what causes allergies, we're at a bit of a loss, to be honest. Molecularly, what's going on at a fundamental level at the causation of the allergy? Yeah, we're struggling to have an answer for you. We've got some theories about things that may contribute. If you have a dog or a cat when you're very young, you're probably less likely to have an allergy. If you're exposed to diesel fumes when you're young, you're more likely to have an allergy, so on and so forth. We know some of these things that are going on, but really a clear picture on the molecular processes which cause allergies, we don't know. Once you've got the allergy, we have a fairly good idea about the molecular processes going on. If you're allergic to peanuts and you're exposed to peanuts, we know what's happening. But what caused that allergy in the first place is still a little bit of a mystery to scientists. So let's go through that response. Seeing as we know it, let's dive into it. Now it starts with the parasitic response. So if you have a parasite in your gut, parasites produce mucus. That mucus protects them from the digestive enzymes. And an antigen presenting cell might eat that mucus, then display that mucus to a T helper cell, along with releasing some cytokines here, the antigen presenting cell. That T cell will then recognize that antigen, recognize these cytokines, and then release more cytokines, and in particular IL-4 and IL-5. Now IL-4 and IL-5 will act on B cells, basophils, mast cells, and eosinophils. So that's a basophil or mast cell, that's an eosinophil, that's a B cell, and it will cause them to proliferate and get activated and primed and get ready, right? Now, when the B cell produces antibodies, it will go out and bind to the mucus on that worm. And then that antibody antigen complex will then be recognized by a basophil or mast cell, and that will cause degranulation. Now, in the granules of mast cells and basophils are histamine. Histamine. Now, you might recognize that when we talk about allergies because often the drug used to treat it is antihistamine. So when this antibody binds to the antigen and that is recognized by the basophil or mast cell, you get massive histamine release. Now, the point of that is to cause a massive inflammatory response because we need innate immune cells to go in and attack that parasite. And we also need to flush out our intestines, for example, or our nose or wherever the parasite is. We need to absolutely flush it out. And to do that, we need to make our blood vessels leaky so fluid rushes out, causing diarrhea or a runny nose. And that can help flush out the parasite. So that's why we need that histamine release to get all those immune cells in there to attack that parasite and to cause the vascular responses essential to get that parasite out of wherever that's in your nose or in your intestine, for example. Now, an allergic response is when this whole process occurs to a non-pathogenic antigen. So here we have some peanuts here. They've released some chemicals. Again, it's gone through the APC, the T cell, and the B cell, and we get massive proliferation of the B cells, the basophils, the eosinophils, and the mast cells. And then we get this process again, but this time it's a peanut antigen that's been recognized by an antibody that was produced by a B cell that binds to the basophil or mast cell, and we get massive histamine release. And then that causes those vascular responses. Now, vasodilation and leaky blood vessels causes massive swelling, right? Because your tissue isn't normally flooded with fluid from your blood massively, but if your blood vessels become leaky, it fills with fluid and immune cells, and it causes swelling. Now, the human body has rather narrow airways due to us walking upright essentially and having to look forward instead of up. And so this can cause a massive risk to essentially stuffing up the airways and causing asphyxia and death of someone who's having an allergic response. And so it's really important we deal with that. Now, we deal with it with antihistamines if it's mild, but if it's major, we deal with it with adrenaline shots or corticosteroids such as cortisol to try and massively dampen down the immune response. So we give it an adrenaline shot typically, and that's because the adrenaline signal is a signal for you to fight or flight, to run, and it's not a signal for you to sit and deal with an immune response, right? So to conserve energy and sort of target your body for a flight or fight response suppresses your immune system, suppresses your digestive processes, for example, and puts all the body's resources into its muscles and its heart and tells it to go. So an adrenaline shot massively suppresses your immune system also. And then cortisol and glucocorticoids also can too. These are stress steroids. But so this again, so you can get blockage of airways. That's a massive risk to your health. But there's another problem going on, and we saw this in a previous video with sepsis, right? If you eat peanuts, you could have a massive systemic immune response where all your vascular system suddenly becomes leaky because the peanut antigen is now flowing around your blood, activating immune cells all throughout your body. It's not necessarily just a local response when it comes to allergies. And so because all your blood vessels are leaking, fluid is rushing out of it, and you can actually have a massive drop in your blood pressure. And that's like a leaky balloon, right? If you pop holes in a balloon, the pressure inside that balloon drops, and that's because your blood vessels have become leaky all throughout your body. Now, to compensate, your heart can try pump more and more blood around to increase the flow, right? Because if you increase the flow, you increase the pressure. It's a bit like trying to pump up the balloon while it's leaking to try and maintain pressure. But if this is left untreated and we don't get an EpiPen injection or any sort of immune suppressants going on to sort of block this histamine response and this leaky blood vessels, we can end up with organ failure, and this is from hypoperfusion, so a lack of blood flow to essential organs causing organ failure. So we need to stop this, and often for milder allergies like pollen, we use antihistamines. So in the next video, I'm going to go through drug development as a general process, and then I'm going to use the example of histamines as a pathway through drug development. So tune in to that. Thanks, guys.